Hi students, welcome to the problem solving session on force and torque on the magnetic field. Let us see this problem. A rectangular loop in the xy plane with sides B1 and B2 carry a current I lies in a uniform magnetic field. B is equal to Bxax, Byay, Bz. Determine the force and torque on the loop. So we have to find force and torque. Okay, right. Where is the loop is kept? The loop is kept in the xy plane. Okay, let us see. This is okay. This is what our xy plane, right? The loop is kept in the xy plane. Fine, right? Okay. What is the side? The sides of the loop are B1 and B2. Let us assume this side is B1, right? And this side is B2. Fine. Right, the current flowing through the loop is I. Okay, and it is kept in a magnetic field, uniform magnetic field. Let us assume this is a uniform magnetic field B. Right, now we have to find what is force. Right, let us assume the loop is A, B, C, D. Right, so if I want to find what is the force, total force on the loop, right, what I do is instead of finding total force, I find what is the force in a conductor AB, BC, CD and DA and add individual force. Right, we know whenever a closed loop is placed in a magnetic field, the net force it experiences is 0 only. That we are going to prove for this problem. Right, the answer is 0. Anyway, it has to be 0. Let us see that. Right, only it will experience torque. So torque will be non-zero. Fine. Okay, let us see that. What is the force along AB? Let us first take this. Let us consider this loop is a conductor. I find what is the force along AB. The force on a conductor is given by, we know, IL cross B. In a conductor placed in a magnetic field, force is IL cross B. So in AB, what is the current flowing? I only. What is the length? Length is B1. But L is a vector. In which direction AB is there? AB is along. So this is X direction, this is Y direction. So the AB is along X direction, A to B. It is going in this direction. So it is AX. Right? Cross, it is not multiplication, cross. B is BXAX plus BYAY plus BZAZ. Fine, okay. Now we see I B1. Okay. Now we take a cross product first. AX cross AX, it is 0, no problem. Next we take AX cross AY, it is AZ. So what I get is B1 BY AZ. Sorry, B1, right? Okay, it is BY AX cross AY AZ. Fine. Next, you see AX cross AZ. AX cross AZ is minus AY. So it is BZ minus AY. Right? So this is what our FAB. Right. Similarly, we can find FBC. FBC is given by I into L. L is along this direction, B to C. So along positive AY direction. The side is B2. The length is B2. So L is B2 AY cross similarly BXAX plus BYAY plus BZAZ. Take a cross product. What you get is I into minus B2 into BXAZ plus B2 BZAX. Okay, this is what FBC. Similarly, we can find FCD. FCD. As usual, current is I, but C2D is going from here to here. It is along minus AX direction. It is going in this direction. So this is plus AX, this is minus AX. So the side is B1, the same length here. B1 into minus AX cross. Similarly, same BX AX plus BY AY plus BZ AZ. So if you simplify, what you get is I into minus B1 BY AZ plus B1 BZ AY. Similarly, we find FDA. FDA is equal to I into, see, it is D to A, D, it is D, it is A, it is coming in this direction here. So it is going along minus AY, this is minus AY, right? So it is going along minus AY direction. So the side is B2, B2 minus AY. See, the length is, okay, here you see the length is B2. This is B2 means this is also B2. So B2, what happens? B2 AY cross BXAX plus BY AY plus BZ AZ. If you simplify, what you get is I into B2 BX AZ minus B2 BZ AX. So here, what is the total force? Total force is equal to F is equal to FAB plus FBC plus FCD plus FDA. If you add all the value, you will get 0 only. So we are proving that the net force on the loop placed in a magnetic field is 0. It will experience only torque. Now we will prove that it has only torque. Now we find torque. Right, the loop is like this. Again it is very difficult for me to go there. So X, Y, this is B1, B2. Okay, so as usual, A, B, C, D. Right, what is the torque formula? Torque is equal to R cross F. What is R? R is the distance from the axis of rotation, right? This is axis of rotation, center. This is axis of rotation. So it's the distance from the axis of rotation here, right? Off the distance only we'll take, right? So what is torque along AB? Torque along AB, distance from the axis of rotation is, total distance is B1, half is B1 by 2 into, in which direction? R is a distance. So A to B. A to B is in, here you see it is in this direction, this side. It is plus Y, right? It is in minus AY direction, right? Because it is plus Y, it is plus Y, it is minus Y. A to B is in minus Y direction. So we write minus AY. This is the way you have to measure, right? So this is plus Y, this is minus Y. This side is plus 6, this is minus 6. Okay, right. So cross F, F is, we know, FAB. FAB we found in the previous FAB we have here, right? Where is that? This is what our FAB, right? I into B1, BY, AZ, BZ, AY. Substitute that, right? So cross I into B1, BY, AZ minus BZ, AY. Okay. If you take a cross product, what you get is I into I into B1, B2 divided by 2 minus BY AX. Right? So we know AY cross AY is 0. So AY cross AZ is AX. So B1, right? It is right, it is B2. What is that? What is the length? What is the length? It is B2 B2 here, right? B1, this is B2. Where is my FAB? Let me check it. FAB I into B1, right? Okay, here R1, R is this A to B, right? So this distance, please, sorry, I have to remember A to B. This is axis of rotation they have taken, so here to here, right? It is B2, right? I write here again. How I am going to do? This is what my conductor is. This is A, this is B, C, D, right? So distance from the axis of rotation, this is axis of rotation, right? So this is plus X, this is minus X, plus Y, minus Y, right? So R, distance from the axis of rotation, this is what B2, it is total distance is B2, here the distance is B1, so it is B2 by 2. This distance is B2 by 2. This distance is B1 by 2. Okay. So RA to B is this one. From the axis of rotation, it is at a distance of B2 by 2. And in which direction? It is below the axis of rotation. So it is minus A here. My conductor is lying in this side. You see, A to B is in this side, so it is at a distance of B2 by 2 in minus Y direction. That's what minus AY, right? So please remember, I think I make some minor mistakes. Okay, so next you see AY cross AY 0. So now AY cross AZ is AX, B1, B2, I minus. Okay, so simple. Next, TBC, torque along BC, lot of issues. TBC is given by, you see, how can we find TBC, B2C here, right? It is what, torque along B2C, right? That is given by, again, what is the distance, B2C? It is B1, the distance from B to C, right? See, whenever it rotates, it is rotating with respect to this direction. It will rotate, right? This will rotate with respect to this direction. Okay, so it will rotate in this way, fine, and this will rotate this way, the bottom side, right? So here, what is the distance? It is going from here, so it is B2 by 2, right? So it is B1, okay, the distance is B1, so B1 by 2. You see, I am writing here this one. I am going to find B2C, right, from the center. From the center, for this is the center, it is B1 by 2, right? But for this one, this is the center. Here it is B2 by 2. That's what, right? So B1 by 2, in which direction? It is along the X direction, positive X direction, right? It is going along positive X, this side. B2C is in this X plus X, so it is in B2C is in plus X side, so AX, right? So AX, what is my B2C, force on B2C? Force on B2C is given by this value, right? So substitute that value, what you get is I into B2 minus BXAZ plus BZAX. So if you simplify, TBC will be equal to I into B1 by B2 by 2 AY BX, right? Okay, this is what TBC. Next to TCD, as usual, the distance CD, right? C to D. Here you see it is C to D, right? So what must be the distance? It is in AY direction. That moreover, it is in positive Y direction, right? It is positive Y. B with respect to this is positive Y. So it is, what is the distance? B2 by 2, right? Total distance is here to CD. From here, the distance is B2 by 2, and it is in positive Y direction. So I into B2. So I into B2 by 2, right? What is the direction? It is along AY direction. So I write, right, okay, CD I into B2 by 2, AY cross, what is force on CD? That is given by I into B1 minus BYZ and plus BZ AY. Fine. So now if you simplify, you get TCD as I into B1 B2 divided by 2 BY minus AX. Right. Similarly, you can find follow the same procedure and find a TDA D2A. You will get I into B1 B2 divided by 2 BXAY. So what is the total torque? Total torque is given by TAB, TBC plus TCD plus TDA. That is equal to I into B1, B2. If you add all the four values, what you get is BX